So again, thanks so much for your time this afternoon. And like I said, this is Dyscalculia Overview for administrators. And if any of you are repeat attendees in our Math Learning Series, well, we definitely welcome you back and thank you for your participation. If you are new to this series, depending on how you learned about it, we do have a web page, and I'll share that with you towards the end of the presentation, where you can go back and view the presentations that we have already recorded. And we also have a few presentations that will be coming up over the next month or so. So we would encourage you to check back with us and attend one of those presentations if it works out for you. But the recordings will be available. And as a follow-up to this presentation, within the next week or so, you will receive an email with a link to that recording, so you can always get to that information. So a little bit of information about Cheryl and me. I actually started my educational career as a high school teacher before moving into central administration, special education, and professional development. Then I went to work for a small educational software company, and we were purchased by Pearson about 5 years ago. And that's how I came to work for Pearson. Cheryl, on the other hand, she is a career educator as well, but she started her life as an elementary school teacher. So you'll get the elementary school as well as kind of the high school kind of perspective. And then she went to work as a campus administrator and then in central administration as well. She is a failed retiree, and she also went to work for that small educational software company before we were purchased by Pearson. And we work within like the clinical assessments division, teaching teachers, teaching administrators, and we also do a lot of online professional development and work very closely together. And I say all that just to let y'all know that we probably have had a position similar to yours, so please ask us questions along the way. We definitely want this to be from the perspective of someone in the classroom out in the field. So please stop us and ask questions. If we can't get to your answer today, we will definitely follow up with you after the presentation. We will also ask a few polling questions. I like to be a little interactive, make sure everybody is listening in, and just kind of see where everybody is in this process. So our agenda, if I can move forward, there we go. We've all probably heard about dyslexia by this point, and some of you may have heard about dyscalculia. I will say that when I first learned about dyscalculia, I heard a number of pronunciations, and I will say I'm going to use my Texas twang and say dyscalculia. But what we're going to do today is we're going to define what it is, talk about how students are identified, some misconceptions that you might hear about dyscalculia, and then we'll talk about how you might see this manifesting itself in the classroom. And then finally, we'll end with steps that you as administrators can take to really help support the teachers and the kids in the classroom. So here's a quick poll. Have you heard about dyscalculia? You know, yes, I'm very familiar with it. Yes, but I don't know much about it. No, I don't know anything about it. And I'm not sure why I put all those question marks in there. So most of you are very familiar with it. That's great. Everybody's very familiar with it. Well, wonderful. Oh, someone said they don't think the survey is working properly. Well, those of you who were able to respond, thank you. It seems like those of you who were able to respond do know quite a bit about dyscalculia, and that's great to hear that that term is out there in the schools and people are learning more about it. So for those of you who don't know, or as a refresher for those of you who do know about it, what is dyscalculia? And it is a brain-based condition like dyslexia, and it has to do with difficulty with numbers and math concepts. And really the crux of the problem seems to be with understanding quantities and being able to recognize and understand quantities. Students struggle with learning and retrieving math facts and concepts, and they have issues with transferring math knowledge into application and reasoning. They often tend to have problems with working memory in that they can't remember numbers and really the procedures that are involved in word problems and equations. And we'll take a look here in just a minute with what some of those might look like. Also, you'll find that people have a developmental dyscalculia in that they are born with the disorder, while others, either due to brain injury or a condition that affects the parietal lobe, and that's really the part of the brain where this disorder seems to manifest itself most, they can acquire the condition after the fact. So you may hear two different terms, developmental or acquired dyscalculia. And so you can see that it can be a varied group of people that can be effective. And in everyday life, you might see that people have problems when they're counting, making change, following directions, so that kind of sequencing of steps, keeping and managing time, recalling schedules, measuring, and really any other kind of number-related tasks. But that's not to say that all math difficulties are due to dyscalculia. And it, like dyslexia, is something that must be specifically diagnosed. And we know that also that, when kids are anxious, or really anyone is anxious about an issue, math or other, it really can exacerbate the problem as well, so it kind of feeds upon itself. So the classification for dyscalculia, it is classified as a specific learning disability in the DSM-5, and it is categorized with problems with number sense, memorization, recall of arithmetic facts, fluidity and accuracy in math computations, and accurate math reasoning and application. When students are diagnosed with the disorder, multiple resources are used. So whomever is making the diagnosis, it could be interviews with the parents or other educators, teacher perceptions, standardized tests, assessments, student grades and performance, and it also can be medically diagnosed. So really, depending on how the condition is diagnosed, students can qualify for under 504 if it's a medical condition, or under IDEA to receive special education services. So the frequency, dyscalculia, again, similar to dyslexia, can occur in between 5 to 10% of the student population. Likewise, the disability can really range from a very mild case to very severe cases. And it can occur in really people of all ages and intelligent levels. It's not just one, lower intelligent levels or higher intelligent levels. And it's also not confined to any particular socioeconomic level, ethnic or language group. And just like with any other condition, it really should be, and hopefully it can be, identified early so that the child can learn strategies to work through what's going on. A study in the UK that I found actually showed that poor numeracy is more detrimental than poor literacy, especially in women. And it goes along with lower wages, lower spending, and poorer health. And it's estimated that problems with numeracy cost the British government a little over £2 billion, or that's $2.5 billion. So you can see it's just not a cost to the students with the students' frustration, but really it's costing us all if we're having problems with poor numeracy. Some students with dyscalculia also show signs of secondary disabilities such as ADHD, emotional disturbances, dyslexia, or dysgraphia as well. Some misconceptions that we might hear about dyscalculia can include that it's a made-up condition for students performing below expectations for their grade levels in math. The misconception that it's associated with a specific personality trait, or that the child will outgrow or unlearn. It occurs because the students aren't working hard enough or spending enough time learning facts. And it's a misconception that occurs because students are not practicing math operations enough. Or the misconception that it occurs because, specific ethnic groups more than others, or is gender specific, or that the students are not paying attention to instruction in math. And again, earlier we talked about the intelligence level. The misconception that trouble with reading and trouble with math are not related. Obviously, with the similarities between dyslexia and dyscalculia, you can definitely see that that's not the case. And then, again, the misconception that some kids just take longer to learn math but will catch up with their peers over time. Just like dyslexia, some symptoms of dyscalculia can vary greatly, but they could include, trouble understanding quantities, and that numbers represent quantities, and we'll look at an example of that here in just a minute. Again, trouble recognizing numbers and their equivalent written words. Weakness in working memory, so problems with lists, shopping lists, phone numbers, important dates, and a weak number sense with ordering patterns and things like that. No kind of feel for numbers, which is more, which is less. Is a baby, 5 pounds or 500 pounds? Unable to make accurate estimations or guesstimates on, how much something weighs. Reordering numbers when writing them. Unable to make conjectures and assumptions from facts, information or graphs. Or the student might lack fluidity with application of math rules and operations, difficulty with counting and sequencing, problems with memory of basic facts, or the over-reliance on counting, especially on your hands into the middle and upper grades, difficulties recognizing number patterns, weakness in visual and spatial orientation, difficulties telling time, making change, following schedules, and other math-related activities. And again, like we said, this can really cause a high deal of anxiety with math-related tasks. So as young children, we have the ability to judge quantities without counting, and this is known as approximate number system. But people with dyscalculia are unable to or have difficulties making these adjustments. And it's frequently, this kind of what we're about to look at is kind of frequently used in assessing or working with students with dyscalculia. You might flash up 2 sets of numbers, and which one has more dots, the one on the left or the one on the right? Well, the one on the left has more dots. There's 25 dots, whereas the one on the right has 11. And I think even with a quick flash, you can see that. But again, someone with dyscalculia is not going to be able to see that difference in the quantities. Sometimes they have different colors. Sometimes the test might be with a single color. And I will say, as I've learned more about dyscalculia, seeing these examples, definitely did send a little light bulb off in my brain of, working with students and even some other people. We also talked about recognizing numbers and their equivalents, either in words or written expressions. So for, again, people with dyscalculia, understanding that the written 3 is the same thing as the number 3 is the same thing as 3 dots. And in one study I actually read, the unable to understand that holding up 3 fingers is the same thing as, the written number 3, the number 3, and 3 dots as well. And this is even more abstract, example of an equivalent. So 1/4, and then we have a pie chart that shows, a fourth colored in. So that would be very, very difficult in their understanding. We also have talked about a weak number sense, ordering and sequencing. So the question, and I was working with some other coworkers on some software, and this is this actually is something that the software works at to test. Is 10 closer to 0 or is it closer to 30? And again, someone with dyscalculia might put 10 way over towards 30, not understanding, where that number is in sequencing. And then we talk about operations, not knowing the operational order for equations. So in this first equation, the student might add each one of the numbers together to get 14. And with the second equation, perhaps they're going to do the outside numbers and then the inside numbers and add those together and get 77. And then if we were to do the equation vertically, adding again the last 2 numbers to get 11 and then the first 2 numbers to get 3. So not understanding that the operational order when working with math. I didn't put this up as a poll question, just as more of a thought. Seeing these examples, do you recognize any of these in your students, or have you heard from teachers that they're witnessing some of these in their students? Again, just more of a thought than a poll question. So in elementary or in our elementary grades, you might see students who rely on counting on their fingers beyond early childhood. They could be skipping numbers when counting. They could have struggles with numeration and base 10 systems of counting. Or they could be confusing number symbols, pluses and minuses. Unable to connect numbers with quantities, we've talked about that, and not recognizing patterns and sequencing, and then making frequent errors in calculations. Difficulties with learning basic math facts. Again, it's not that that we need to keep going over them again and again, but understanding